welcome back to the ZSL Wild Science Podcast. I'm your host, Harriet McAra. I'd like to start by painting a picture. Deep in the dense forests of southern Chile lives a tiny amphibian. Just 3 centimetres long, expertly blending into the browns and greens of the forest floor, with a narrow pointed nose and an angular body, the Darwin's frog is fighting for survival. Not only do these animals look unique, that is, if you can even spot them, but they have a remarkable parenting strategy. The males of the species care for their tadpoles within their vocal sacs until they're developed enough to emerge out of dad's mouth as tiny, fully formed froglets. But looming over the Darwin's frog is an immense threat: chytrid fungus. This devastating disease is wiping out amphibian populations across the globe, and the Darwin's frogs in southern Chile are no exception.
So there are 2 species of chytrid fungi that are like the most important for amphibians. There are many other species of chytrids, but the others are not pathogenic to amphibians. So we have the Batrachochytrium dendrobatidis and also the Batrachochytrium salamandriborans. The most concerning for amphibians in general is the Batrachochytrium dendrobatidis, or BD for short. And these chytrid fungi are microscopic pathogens that infect the skin of amphibians. And in amphibians, the skin is a very important organ because they can exchange electrolytes, oxygen, but also water.
That was Dr. Andrés Valenzuela-Sánchez, Research Fellow in Wildlife Health at ZSL's Institute of Zoology and President of the Chilean NGO Ranita de Darwin.
I work with wildlife diseases, so that is or wildlife health, that is my main focus of research. I am originally from Chile in South America, so for most of my professional career I have been working with amphibians from Chile and with the chytrid fungus, that is a pathogen that produces an infectious disease that is a main threat to amphibians. So the infection of the skin by this pathogen produces an osmotic imbalance and also a problem in different organs in the system of the amphibians, which causes a heart failure, which is the main cause of the death of the animals.
And although global declines of amphibian populations are recognised as one of the most important biodiversity crises facing us today, it's only recently that infectious disease, such as that from chytrid fungus, has been considered as part of the equation.
This is a relatively recently described disease. So the first description of the pathogen and the associated disease and population declines in amphibians was published in 1998. It was a team of researchers from all over the planet, and ZSL's Professor Andrew Cunningham was part of the team that described this pathogen and the disease that is called chytridiomycosis.
It's a really fatal disease too, known to kill around 85% of infected Darwin's frogs. So I'd like to move on to talk about Darwin's frogs, if I may. Can you tell us a bit about the species? Why are they so unique?
There are many things about Darwin's frogs that make them unique. So first you need to know that there are 2 species of Darwin's frogs. So there is the northern Darwin's frog, or Rhinoderma rufum, and the southern Darwin's frog, or Rhinoderma darwini. And both species are very unique. Both of them are edge species, which means evolutionarily distinctive, and globally endangered species. So from an evolutionary point of view, they are very unique, and they have a reproductive strategy that is unique among the over 9,000 human species that we know in the planet. And this reproductive strategy is that the male of the species brood the tadpoles, the ones that we normally see swimming in water. In this species, the male brood the tadpoles inside the vocal sac. The vocal sac is the same structure that frogs and toads use during their calling behavior. But in this species, they use it for calling, but they also use that structure for brooding the tadpoles. And in the southern Darwin's frog, that brooding is what we call complete, because the tadpoles will develop inside the vocal sac and they will do the metamorphosis. They will transform into small froglets. And after that, the male will release the froglets into the forest floor.
Yeah, it's truly an incredible thing to see. I'll put a link to a video in the show notes for this episode so listeners can see those tadpoles moving around inside the male frog's vocal sac. It's almost alien. How many might they be holding in there at one time?
The maximum number that is described is 22 tadpoles, so it's a large number. But normally you see, it will depend on the population that you are studying. But normally you see between 10 to 15 tadpoles. So it is still a large number. Yes.
Yeah, to see all of those tiny froglets coming out of the mouth of a male frog must be something else.
So Andres, you mentioned that you are originally from Chile, which is where you do a lot of your work. Can you tell me about the state of amphibian populations in the areas of Chile that you work in?
Yes. So I have been working in different places in Chile. An important comment for the context is that the northern Darwin's frog hasn't been seen since 1981. So over 40 years ago, that was the last time that we saw or have any record of the species. So my work has been focusing mostly on the southern Darwin's frog. And this species has a relatively large distribution in Chile and also in a small area in Argentina. So I have been working across the entire distribution, but I have 3 or 4 sites that are like my main research areas. And one of them is Chiloé Island. Chiloé is actually an archipelago, so it has many small islands, but it has the main big island is also called Chiloé. Okay. And I work in one particular area in that main island that is in the southern part of the island. And Chiloé is important, at least the archipelago, from a historical point of view, because it was in this place that Charles Darwin, when he was in Chile, collected the species for the first time for the scientific description of Darwin's frogs. And that is why the species is called Darwin's frog.
Okay.
Yes.
Wow, that's amazing.
Yes, so this area that we are studying in Chiloé is called the Tantauco Park. It's a large protected area in Chiloé. And this area was very important because the largest known populations of the species were in that place. So we have been doing this monitoring across the whole distribution of the species, our team, but also other people working with the species. And we know that the largest known populations of the species were in that park. And the other populations of the species are much smaller than the ones that were in that area. Unfortunately, in 2023, we recorded the introduction or invasion of the chytrid fungus in that area. And following the invasion of this pathogen, these populations collapsed in just 1 year. Most of the frogs that were there, the Darwin's frogs, disappeared. And we have evidence that it was associated with the chytrid fungus.
And there were some recent developments that came out of your work in Tantauco related to the transmission, the spread of the disease in the water versus on land, is that right?
Yes, so that is a very important characteristic of BD, the chytrid fungus, is that this fungus is an aquatic pathogen. So it has 2 main life stages. And the infective life stage, which is the one that is going to find a new amphibian and to infect that new amphibian, is an aquatic zoospore. It's like a very small organism that is going to be swimming in water. And an important characteristic of Darwin's frogs is that they are fully terrestrial. As they have developed this reproductive strategy where they don't need to use any water body to complete their life cycle, they are not associated with ponds or streams or any body of water. So they are fully terrestrial. They live inside the forest in the terrestrial environment. So we didn't understand very well how the chytrid fungus and specifically the infective stage of the chytrid fungus, could infect the Darwin's frogs. And this is the same not just for Darwin's frogs, but for other fully terrestrial amphibians. So we tend to think that amphibians are always associated with water, but in reality there are over 1,000 or even more amphibian species in the planet that are fully terrestrial. So understanding the dynamics of the disease and the transmission of the pathogen in this terrestrial system is very important for other species as well. And what we found in one of our studies is that even in these terrestrial systems, the fungus is capable of being transmitted between different Darwin's frogs just by the contact of different individuals of this species. Wow. So within one population, if you get one Darwin's frog infected, the fungus is capable to be transmitted in that population just by the contact of these animals. And this transmission is able to produce population declines in this species. So what we think that happens in nature is that the density of Darwin's frogs is very important for the spread of the disease. So in populations where the density is very low, so you have very few animals, very few Darwin's frogs, the pathogen cannot be transmitted effectively. Mm-hmm. So it will disappear or not produce these population crashes. But when the density is high, as it was in Tantauco, those Darwin's frog populations were very large, the fungus can produce these rapid declines and population collapse.
Oh wow, that must have been a really concerning discovery when you found that the disease could spread on land from infected individuals as well as in water.
It was concerning from a kind of scientific point of view, but also for me personally it was very concerning because we have been monitoring that population for since 2010, that area. And my team and I went there for all that period, every year. During some years, we went there many times during a year. And that population was very important for us, like emotionally, because we knew the frogs very well. Many of our research papers were focused on that population. From a conservation point of view, it was a very important population. And despite we knew that the chytrid fungus was a main threat to the species, this was the first time that we saw, like in real time, a population crash, collapse in a short period of time in this species associated to the fungus. So when we saw that in Tantauco, and then we discovered that the fungus is able to be transmitted between Darwin's frogs effectively, it was like a devastating news for us.
Yeah, I can imagine. I promise we'll move on to more positive topics soon, but can you quickly tell me about some of the other threats that the species is facing?
Yes, so for Darwin's frogs, as for most of the other amphibian species in the planet, the main threat is habitat loss and degradation. In the case of Darwin's frogs, it's the loss of the native forest. So this is a fully terrestrial species, and it's also a forest specialist species. So they live always inside the forest and inside native forests. They are more abundant where the forest is undisturbed and very old, and you have this mature forest. Historically in Chile and in Argentina, in some areas, there has been a change in the land use. And the other important threat is climate change. So for all amphibians, they are very susceptible to any change in the climatic conditions. So that is also an important threat for the species.
A really fine balance there, I'm sure. So at ZSL, we're creating change for the Darwin's frog. We're supporting captive breeding programs and developing long-term strategies to protect these animals in the wild. More on that later. But Andrés, let's start with the captive breeding. You have an absolutely brilliant story about relocation of the Darwin's frog from Chile to London Zoo.
Yes, that was a very interesting project that I was involved. So when we saw this massive decline in the population in Tantauco, we rapidly contacted different partners in Chile, but also in other places. And we decided that we needed to do something. So we have a kind of an alliance or a conservation strategy that groups together many different institutions. And with the members of this conservation strategy, we designed a project for rescuing the frogs in Tantauco, but also the project is intended to recover these populations in the long term. So the first emergency action of this project was to at least safeguard the genetic diversity and the few individuals remaining in Tantauco after the invasion of the chytrid fungus. And the only institution that was ready for receiving the frogs in this emergency action was the ZSL London Zoo. And that is why in October 2024, we did a rescue of 53 Darwin's frogs that were transported from Tantauco to London. All the process, it's quite incredible because it was a very long journey. I can tell you more about that later. But I also wanted to add that after this rescue, we did a second rescue in January 25 of frogs that were transported from Tantauco to a captive breeding facility in the country. So now we have 2 ex situ populations of the species that will be used in the future for reintroductions into the park in Chiloé.
Oh, amazing. I'd love to hear more about that epic journey.
So yes, the journey was quite incredible. So you need to consider that the Tantauco Park is in a very remote place in the Chiloé island. Actually, the area where these populations were is in a place that you can access only by boat or by a small aeroplane. Okay. So there are no roads getting to that area. And this place is very far from London, of course. So for transporting the frogs from Tantauco to London, we decided that the safest way was to start the trip by boat. Mm-hmm. So we took a boat from Inio. Inio is the place where the populations are. And that boat took us to one of the main cities in the Chiloé island. Just that trip was 6 hours long.
And how are the frogs stored?
That is also an important detail. The trip was very long, and for the frogs to survive this long trip, we needed to make sure that the conditions of the transport crate or transport box were adequate for the species. And as the frogs needed to take an aeroplane for getting from Chile to London, we couldn't use any electricity or battery in this transport box. So we designed a transport box that has like different layers. The outermost layer had this kind of ice packs for keeping the temperature low. Mm-hmm. So in amphibians, when you keep the temperature low, their metabolic rate is reduced, so the animals will be more relaxed and less stressed. And inside this layer, we had the box with the frogs. And as we wanted to reduce any possibility of animals transmitting the chytrid fungus between different animals in this box, we transported them like in individual tubes inside this box. And inside these tubes, we have a layer of moss that was very humid for them to have like the right level of humidity during the trip. So we put this box in the boat, and we got the box to one of the main cities in Chiloé. And from there, we traveled by car from that place to Santiago, which is the capital city in Chile. That trip was 15 hours long, non-stop. Oh. So we had like a team inside the car, and we take like turns for driving and to be able to do the trip non-stop. We wanted to keep the time as like the duration of the trip as short as possible, and that was the shortest option. And from Santiago, the capital city, the frogs were there like for 3-4 hours, and then they were flown in this aeroplane from Santiago to London Heathrow. That flight is 16 hours long. So in total, the frogs were in the transport box for 52 hours. and the distance that they traveled was 13,000 kilometers.
Wow.
And the good news is that all the frogs arrived in very good health at the London Zoo. And actually, after their arrival, a few males started calling, like a few hours after their arrival, they started calling and having like their normal behaviors.
That's amazing. And presumably you didn't look inside the box at any point during the 52 hours?
No, we did.
You did?
Yes. So after the trip on the boat, I personally checked the transport box to see that the frogs were okay. We were also measuring the temperature inside the box to make sure that the temperature was low.
Yeah.
This was in October, and Santiago, the capital city, in October can be quite hot, so you can have easily 30, 32 degrees. But this species is from cool forest, so we wanted to make sure that the temperature inside the box was low.
Yeah.
And after the trip on the car, I checked again that the frogs were healthy before the longest trip that was on the plane.
Yeah. Oh, you must have been so relieved to open that box at London Zoo. Did you check in Heathrow or when they got to the zoo?
No, so I was in Chile, so I stayed for a few days. I didn't take the same flight. So it was Ben Tapley, my colleague at ZSL. He's the curator of amphibian and reptiles. And he was here at the facility in the London Zoo for opening the box. Wow. So he was so happy, and he texted the whole team after he opened the box, and telling us that the good news that the frogs were all okay and healthy. Wow. Yes.
And there has already been some breeding success, is that right?
Yes. So the frogs that flew from Chile to London, we had some males that were already brooding tadpoles. So they were transported brooding the tadpoles. So we had newborns from those tadpoles that flew from Chile. But also in the zoo, we already have seen a reproduction and breeding of the animals that are in the ex situ population. Amazing. And we already some newborns that were completely bred in the zoo.
Oh, that is so nice to hear. So I'd like to talk about the link between amphibian rescue and ex situ research. So that is scientific research being carried out here at the Institute of Zoology, for example. How is the work you're doing here aiding conservation outcomes for animals in the wild?
Yes, that is a very important point, because the export permit that was granted to us by the Chilean government included consider not only the reproduction of the animals ex situ or in captivity, but also the research of the chytrid fungus. So the main goal is to find ways for the frogs to fight the chytrid fungus. So the reason why the frogs are here is for their breeding, but also for doing research that will inform in the future reintroductions that will be safe for the species. So we cannot reintroduce the species now because the chytrid fungus is still present in the wild in the Tantauco Park. So first we need to find ways for the animals to survive or to give them the best chance for survival before we can do those conservation reintroductions. Mm-hmm. And that is one of our main goals with this ex situ population.
So you've mentioned a few other partners that you work with on this, but how important are the collaborations you have with other NGOs, scientific institutes and local communities for this work?
So we have many different partners. One of our main partners is a local NGO or a charity that is called Ranita de Darwin, which is the name of the species in Spanish. And this NGO, they work with different local communities and also with some people that are managing protected areas, both private but also public protected areas. So through this work, we collaborate with different local communities that they have like a regular interaction with the species, but with some communities that they also manage the land where the species is. So that is very important for not just for the research and conservation work related to the chytrid fungus, but also for protecting the habitat, so the species can, even if the fungus is there, can have a better chance of surviving the disease. And all this work is under the umbrella of what we call the binational conservation strategy for Darwin's frogs, which is basically a species conservation plan that gathers together more than 20 different organizations from Chile, Argentina, and also a few from Europe. And this conservation strategy was started in 2017, and since then we have been collaborating with these institutions in defining what are the most important actions that we need to do or implement for saving these species.
So, on that point, what do you think the future looks like for the Darwin's frog? Or any plans that are in place to implement conservation action?
I am quite optimistic because we have bad news related to the chytrid fungus and to the current state of the species. But we also have very good news that we have been receiving during the last few years, and it is that organizations, but also the general public in Chile, Argentina, they are more willing to protect the species. So for example, in Chile we have a legislation that gives some sort of legal validity or recognition to species conservation plans. And this year, at the beginning of this year, one of these plans for Darwin's frogs was approved by the Chilean government. And this means that the different government agencies in the country will dedicate time and resources to protect the species actively, like to implement actions for the conservation of the species. But we have also seen that the public has been engaging in the conservation of the species. Actually, the news about the approval of this species conservation plan in Chile was covered by the main media outlets in the country. We saw a lot of engagement from people in social media, but also in other places. So I am optimistic that there is a real concern, but also engagement from people in protecting this species. And this will make a huge change in the status of the species. I am sure of that in the following 10 or 20 years.
Oh, it's so great to hear your optimism for the future of the Darwin's frog. And also to hear about the work and dedication from such a wide range of people from so many countries that keep that progress moving forwards and make sure that plan for recovery is implemented.
Yes, I fully agree.
Great. Oh, it's been so lovely to have you on, Andrés. Thank you so much for joining me.
Thank you, Harriet. Thank you for having me.
Hopefully my conversation with Andrés has given you an insight into the vast amount of work, dedication and often patience needed to tackle such huge conservation challenges. But even with all of those things, there is one crucial element required to make this work possible. You guessed it, money. I spoke to Will from the Postcode Lottery to chat more about how the unrestricted funding they give to ZSL, funding that comes from players of the Postcode Lottery themselves, contributes to both the in-situ and ex-situ conservation work we do, which includes the fantastic international rescue of the Darwin's frog.
Hello, my name is Will Humpington. I'm the Climate Change and Environment Advisor at Postcode Lottery.
It's great to have you, Will. Thank you so much for joining us. So we've heard from Andrés about the incredible work being done here at the Institute of Zoology at ZSL to better understand amphibian disease, specifically thinking about chytrid fungus, and the importance of this for aiding in situ conservation, so conservation where these animals are living. Can you tell me a bit about where players of the Postcode Lottery come into that?
Yes, sure. So since 2005, Postcode Lottery players have raised 1.8 billion for good causes across Britain and internationally. As it stands, players raise more than 20 million every month for good causes. Players support thousands of charities of all sizes, from major organisations to local grassroots groups across sectors including health, environment and community initiatives. And best of all, over 7.7 million have been raised by our players for ZSL.
That is quite an astonishing amount of money, actually, really, isn't it? But this money's coming directly from players of the lottery, is that right?
That's right, so players play £12 per month for their Postcode Lottery tickets, and a minimum of 30% of each ticket goes directly to charities. It's a subscription model which provides a sustainable and reliable source of funding for charities, enabling long-term support.
That's amazing. So there must be a lot of charities that benefit from this, but how does the Postcode Lottery prioritise? How do they decide which charities their players support? And maybe a second part of that question, what is it about ZSL's work that makes them such a good candidate for this funding?
Yeah, great questions, and there are a lot of charities, a lot of good causes out there, and what we do is we follow a charity assessment process to develop a clear picture of a charity and understand the difference that funding from our players would make in supporting the delivery of that charity's strategy. And that's where our funding model really excels and is different to some other forms of grant funding. We look for partnerships, and funding is awarded on a flexible or unrestricted basis to support the execution and delivery of the strategy. Funding is trust-based, so we look for charities that have a track record of excellence and expertise, and funding support is long-term, year after year, which is vital for effective management and planning. So we take the way in which we fund and combine this with the specific trust funding strategy, which may identify thematic priorities and broader areas of interest. And we then use this as a lens to scrutinise the charity's own strategy and the difference they are seeking to make. And we also want to safeguard that funding raised by our players, so we assess governance structures, senior management, policy and organisational culture. Our players are interested in hearing about our charity partners, so seeing and hearing how charities communicate their impact is also vitally important in terms of how they tell their story.
So what do projects like this mean to players of the Postcode Lottery?
So this funding makes it possible for ZSL to lean into their strategy focus, and for ZSL it will help prevent extinctions, strengthen scientific and veterinary capability, and then lead on international conservation action, and perhaps most excitingly train that next generation of conservationists. And it's not just our friends the Darwin's frogs. The funding from Postcode Lottery players to ZSL means that as it's flexible and unrestricted, it can be used to support foundational species recovery work across the globe.
What would you like to see, or maybe what would the Postcode Lottery like to see for the future of this project and of ZSL's work in general?
Well, we know that effective conservation is really challenging. It's long work, it's tough, it requires a lot of expertise, and we're delighted in the role that we and our players are playing in supporting over long term this really intentional work. And we're also courageous, and so we like to support those who are ambitious and seek to change the world.
What a lovely note to end on. Thank you so much for joining us, Will.
My pleasure, thank you.
Without this support from players of the Postcode Lottery, work of ZSL scientists such as Andrés in saving species from the brink of extinction, training conservationists around the world, and supporting our vision of a world where wildlife thrives would be an even greater challenge. Thank you so much to Andrés Valenzuela-Sánchez and to Will Humpington for taking the time to talk to me for this episode. To players of the Postcode Lottery whose vital support for ZSL allows us to protect and restore wildlife around the world, we're so grateful. And finally, thanks to you for listening to this episode. Please do leave us a review. It only takes a few seconds and it really helps other people find us and learn about the amazing work of our scientists and conservationists here at ZSL. See you next time.